Hi everyone, so today's lesson is all about dilations. The definition is that dilation is a transformation in which a figure is made larger or smaller, meaning there is a change in size, but no change in shape. So no change in shape. So look at these two examples. For the first example, I want you to tell me whether the blue figure is a dilation of the red figure. And as you can see, the shapes did not change. However, the shapes, blue shape became bigger, or the red is bigger than blue. So the blue is a dilation of the red. So yes, blue is a dilation of the red. If you look at B, there is no change in size or shape. So these two figures are the same size, same shape. Therefore, this is not a dilation because dilation needs to be different size. So this is a no. Blue figure is not a dilation of the red figure. This transformation is a translation. Remember translation back in 2.1, I believe, or 2.2? It's a slide. Translation is when you move left, right, up, or down. So this figure probably just moved right and down or down and right. Doesn't matter. But this is a translation, not a dilation. So in dilation, there is something called a scale factor. This is also known as K value, a small k, letter K. And this, what it does is it's a ratio, basically a ratio of the side lengths of the image to the corresponding side lengths of the original figure when you're dilating. Meaning, let's say I had a coordinate x and y, let's say 2, 3. The rule here is that I'm going to multiply all my coordinates with the value of k. So it becomes k times x and k times y. So in a numeric example, if I set k value is 3, right? If I set k is 3 or scale factor is 3, then I would have to multiply all my coordinates of my figure with a 3. So 2 or 3 times 2, comma, 3 times 3, which is going to be 6, 9. So my 2, 3 original became 6, 9 in the image. So in other words, when I'm given a value of k, which is my scale factor, I'm going to multiply k to all of my coordinates for each vertex of the figure to get the image from the original. So another important piece of information that you need to know is when k is greater than 1. When k is greater than 1, the dilation is an enlargement. It becomes bigger. The new figure, new image will become bigger. And when k is greater than 0, not a negative number, and k is less than 1, which means k is in between 0 and 1, the dilation is a reduction. So let's talk about different examples here. So here is a question. I want you to draw the image of ABC, which is going to be A prime, B prime, and C prime, given that the scale factor is 3. K is 3. Or if the textbook or the question says scale factor is 3, then that means the same thing, K equals 3. Draw the image, identify the type of dilation. Is it an enlargement? Is it a reduction? So let's first graph it, because we were asked to graph or draw the image. I know that scale factor, what I'm going to do is I'm going to multiply all my points by 3. And that's the definition of dilation. You're making the original pre-image bigger or smaller. So let's see what A prime. 1 times 3 is 3. 3 times 3 is 9. So that's A prime. B prime, let's do all the math first. 2 times 3 is 6. 3 times 3 is also 9. And then C prime would be 2 times 3 is 6. 1 times 3 is 3. And these are my coordinates for the image. So my A prime would be 3. And I go all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's A prime. B prime is 6. So that's 3, 4, 5, 6, 9. So identify the type of dilation. This is an enlargement. We can add here because our scale factor K is greater than 1 because our K was 3. Here's another question. Draw the image when scale factor K is equal to 0.5, which is the decimal. And I already know by looking at the definition from before, when K value is less than 1 but greater than 0, so in between 0 and 1, it's going to be a reduction. So my figure, its image will be smaller because it's a reduction. But let's verify. So I'm going to multiply this with all of my coordinates for each vertices, right? Each vertex. So times 0.5 times 0.5, and you guys get the idea. I'm multiplying 0.5, basically reducing by 1/2. Okay, so my W prime will be half of negative 4 will be negative 2. Half of negative 6 is negative 3. X prime, half of negative 4 is again negative 2. Half of 8 is 4. Half of 4, so Y prime, is 2. Half of 8 is 4. And then Z prime, half of 4 is 2. And then half of negative 6 is negative 3. So let's graph that. Negative 2, negative 3. That's W. Make sure you label everything. Negative 2, 4. 1, 2, 3, 4. It's X prime. 2, 1, 2, 3, 4 is Y prime. And then 2, negative 3 is Z prime. And then it's a better idea to have a ruler, but I'm going to try my best to draw straight lines. And that's going to be my image. Identify the dilation is my last part. This image right here, the blue, is a reduction because this K is greater than 0 and K is less than 1. So it's in between 0 and 1.